in class. So in reference to the gas law we started earlier, this is number 7 of the previous question I gave to you. And looking at this question, from all the parameters that are stated here, volume, pressure, temperature, you can see that nothing is kept constant here. Pressure is not constant, temperature is neither constant. So with this, we know we can define this in reference to general gas equation. So from the question here, 20.0 dm cube of hydrogen were collected over water at 17 degrees Celsius and 79.7 kilonewton per meter square pressure. First up, calculate 1. The pressure of dry hydrogen gas. 2. Volume of dry hydrogen gas at STP. Of course, STP means standard temperature and pressure. Now, it is okay to collect a gas over water if the gas is not soluble in water. It is okay to collect a gas over air if the gas is not part of air. But if a gas is part of air, or when the gas combines with air to undergo combustion, you cannot collect it over air. So it is very possible to collect hydrogen gas over water because hydrogen gas is not soluble in water. And the reason why we cannot collect it over air is because when it combines with oxygen in air, it will undergo combustion reaction. But the question is, since we are collecting this hydrogen gas over water, by what means can we collect over water? Is it by downward displacement or by upward displacement? If we check the vapor density of hydrogen, it is lesser compared to that of water. What is vapor density? That is the total number of volume of and the equal volume of hydrogen at standard temperature. That is what vapor density is. And we know that vapor density is equal to what? RMM divided by 2, which means that RMM is equal to what? 2 times VD, 2 times vapor density. So that is how we can get vapor density. Once you get the RMM of a substance divided by 2, you get the vapor density. Like the case of hydrogen gas now, H2, which is what? 1 times 2 to give us, that's the RMM. For you to get the vapor density, let's say VD is equal to what? 2 over 2, that's what? 1. Compared to that of water, and we know that the vapor density of water is going to be 9. How do we get that? 1 times 2 plus 16, this is what? 18. So now that's the RMM, and RMM is equal to what? Or let's take vapor density direct. Vapor density is equal to what? RMM over 2, which is what? 18 over 2, that was what? 9. Compared to that of this one is higher. So that of hydrogen is lesser, so you can collect by downward displacement. So now, let's go back to the main question. The question says that 20.0 dm cube of hydrogen were collected over water at 17 degrees Celsius. This 20.0 will be our V1, 20.0 dm cube. And of course, the temperature we have there is our T1, which is what? 17 degrees Celsius plus 273. This will give us 290 Kelvin. And of course, we also have the pressure, P1 there. Our P1 is 79.7 kilonewton meter square. But the question now is that, look at, we're told that we're given a vapor pressure, and since this gas is collected over water, this pressure of the gas will be what? Will be wet. For us to get the pressure of the gas in a dry form, we have to remove the vapor pressure from the pressure of the gas which is collected over water. So that means we are going to remove this vapor pressure. Normally, when you see a question that contains vapor pressure, it means that you are dealing with a wet gas. So you have to remove the vapor pressure from the pressure of the wet gas so that you can get your P1. That is the pressure of the dry gas. So once you remove 1.90 from here, it's going to give us 77.8 kilonewton meter square. This is the pressure of the dry gas. That is for A. Then for B now, how do we go about the volume of the dry gas? Of course, we have our V1, we have T1, we have P1 now, which is 77.8. This is not our P1. Our P1 is this minus this. So now, how do we get our P2? Our P2 will be our standard pressure, which is what? 101.3. So in reference to standard pressure, in reference to kilonewton meter square, that means it's going to be what? And it means just Newton meter square is going to be 1.01 times 10 raised to the power 5 Newton meter square. And it means Pascal they give to us as our P1. Maybe our P1 is in Pascal. So your standard pressure P2 for that one is going to be 101.325 Pascal. If it's millimeter of mercury, of course, you know it's 760. If it's atmosphere, 1 atmosphere, of course we know that. So now, for T2, our T2 is going to be what? 273 Kelvin. And what else do we need again? We're looking for the V2 now. So find our V2. Remember, P1 V1 over T1 is equals to P2 V2 over T2. We cross multiply here. So if we have P2 V2 T1 is equals to what? P1 V1 T2. We are looking for V2, so we divide both sides by P2 T1. P2 T1. This cancel this cancel this. So V2 will now be equal to, what's our P1? 77.8 times V1 is 20 times T2 273 over P2, which is 101.3 times T1, which is 290 Kelvin. Whatever you do from here, the answer should be in DMK. That is the V2 that is gotten right there. So we have talked about vapor density now. So let the camera be placed there for a while, in case there will be need for her to copy it out. So let me take you to I guess this is taking now. So let me take you to terms on vapor density. How do we solve? I already told you what vapor density is. That is the total number of volume of a gas, which is compared to the equal volume of what? Of hydrogen gas at the same temperature. So right here now, if we have what's it called? If I say find the vapor density, or calculate the vapor density. Calculate the vapor density of sulfur 4 oxide. 1 sulfur 4 oxide, 2 ammonia, 3 hydrogen sulfide, 4 hydrogen chloride gas. How do you find the vapor density of each of them? Take the first one, SO2. Remember I told you that since relative molecular mass is always 2 times Vd, so that means Vd is equal to what? Relative molecular mass divided by 2. Once you get the relative molecular mass divided by 2, you get your Vd. So let's find the relative molecular mass of SO2, sulfur oxide. This sulfur has atomic mass of 32 plus oxygen, which is what? 16 times 2. 16 times 2 is 32 plus 3, that was 64 grams per mole. So that is our RMM. Of course, our Vd now will now be equal to what? 64 divided by 2. So that will give you what? 32. And of course, for the second one, NH3. This one is what? 17 plus what? 14 rather. It's 14 plus 1 times 3 equal to what? 17. That's the RMM. RMM is equal to 17. And of course, since we know Vd will be equal to what? RMM divided by 2. Our Vd here will be equal to what? 17 over 2, which is equal to what? This should give us 8.5, right? So that is the answer to that one. I guess you can take care of the remaining ones as long as you understand. What vapor density is all about. Once you know the RMM, divide it by 2, and of course you can get it from there. Okay. Looking into ideal gas equation. What do you understand about ideal gas equation? This ideal gas equation, I've told you what an ideal gas is. Ideal gas is a gas that obeys Boyle's law and Charles' law at all temperature and what? Pressure. Do you understand? So that's what ideal gas is all about, and it's a combination of Boyle's law, Charles' law, and Avogadro's law. Remember that Boyle's law, volume is inversely proportional to pressure, is for Boyle's. And of course, for Charles' law, volume is directly proportional to temperature. This is Charles' law. And of course, for Avogadro's law, we know that equal volume of all gases at the same temperature and pressure contains number of what? Molecules. So V is directly proportional to what? To N. So they are the same, directly proportional. So this is for Avogadro. The full name of the man is called Amedo Avogadro. So that's what this law is all about. So if I'm to combine this together now, I'm going to have what? I'm going to have V directly proportional to what? N times what? 1 over P times what? T. So from here, what am I going to have here? Since this one is directly proportional to this one, so we are going to have what? PV is equals to what? NT, right? So that's what it's going to be all about there. If we carry out any cross multiplication here, this one, we don't even need to cross multiply. Because already here, if we have equal to this one multiply this one, we have this already. So let's just put times here. So here now, we are going to introduce a constant. And the constant we are introducing here is R. This R means molar gas constant. We call it molar gas constant. So that's what it's all about. If I'm to introduce it here now, I'm going to have PV is equals to what? nRT. Of course, how do we get the molar gas constant? We can make it the Sawyer formula. Let's get the value for the molar gas constant. That means if you're making this one the Sawyer formula, R will be equal to what? PV over what? NT. When R is equal to the pressure is 1 atmosphere, we are going to take volume. Volume of a gas at STP is what? 22.4 dm3. Number of mole 1 times temperature, which is what? 273. So our R here will give us what? So it's likely to give us
0.00.
Supposed to give us 0.082 atmosphere. For pressure, we go to volume, dm3 mole per Kelvin. That's the unit right there. So this is the value for molar gas constant. But in case of some kind of crazy question, there are some kind of things that we need to introduce here. Yes, there's number of mole here. What is mole? What is mole? We have done it in one of the previous class. Mole is the amount of substance which contains Avogadro's number of particles. So I'm going to rub off these parts, then so that we can chip in some things here. Remember this formula that I said, PV here is equal to nRT. PV is equal to nRT. Now we are going to take mole as a concept here. Number of mole can be defined in so many ways. You can define mole in respect to reacting mass over molar mass, which is what? M over capital N. You can define number of mole is equal to what? Volume occupied over molar volume, which is what? 22.4 dm3. Mole can also be defined in reference to what? You can take concentration, con times what? Volume over 1000. This is concentration and this is volume. And number of mole is also equal to what? Number of particles. Number of particles over Avogadro's constant. Avogadro's constant, which is what? 6.02 times 10 raised to power 23. You understand? So that's what it's all about. So right here now, I'm going to chip in some things from the equation. Remember that number of mole is equal to reacting mass over molar mass. I'm going to chip in that here. That's the only one I need, except if there are some crazy questions that demand the rest. So here now, since we know that number of mole, I can chip this one here. I'm going to have PV is equal to, instead of this N, now since I said this one is equal to this, I'll just take number of mole is equal to mass over molar mass R times T. So here I'll cross multiply. By cross multiply, I'm going to have pressure times volume times molar mass equal to mass times molar gas constant times temperature. If I'm to make something as a formula here, I can make the mass, the Sawyer formula. So I'm going to have divide both sides by what? Or divide both sides by volume to say, let's divide both sides by volume. So which means that volume cancel volume here. What am I going to have here? Pressure times molar mass is equal to what? Mass over volume times molar gas constant times what? Temperature. Recall that mass over volume is equal to what? Density. Density is equal to mass over volume, which means that pressure times molar mass is equal to what? DRT. We can take any of this formula to solve whatever kind of question that we need. So let's take some questions on mole concepts before we now go into the ideal gas equation proper. So let's take questions.
How many molecules of oxygen are present in 1.0 dm cube of the gas at STP?
Okay, I think I need to write that one out. How many watts?
How many molecules of oxygen are present in 1.0 dm cube of the gas?
How many molecules of oxygen are present
in 1.0 dm cube?
Present in 1.0 dm cube of what?
Of the gas.
Of the gas.
At STP.
the gas at STP. When you hear how many molecules, according to the question that we said, according to the formula I gave to you on mole concept, the last formula I said, number of moles is equals to number of particles. Anytime you hear how many molecule is a particle, atom is a particle, electron is a particle, proton is a particle, neutron is a particle. So when you are dealing with anything, any question, when they say how many molecules, it means that they are asking you how many particles of oxygen. And the formula that deals with that particle is number of mole. Number of mole is equal to number of particles over Avogadro's constant, which is 6.02 times 10 raised to the power 23. But there's a problem here. We cannot use this directly. Since this is what they say we should find, the number of particles, which is the molecule. I've told you already that molecule is also a particle. So when you see a question like this, formula must come in. But you might need another formula to get something that two things are missing here. We are looking for this and we don't know the number of mole. But from the question, we have volume to be 1.0 dm cube. And since we know volume to be 1.0, we can use number of mole is equals to volume occupied over molar volume, which is 22.4 dm cube, to find our number of mole. So of course here, number of mole is equals to 1.0 over 22.4 dm cube. N is equals to what? Zero point zero four four six. 0.0446. Okay, so that is the case of that. We can now chip that in here and find the number of particles. Number of mole is equals to number of particles. We already got number of mole, which is 0.0446, is equal to number of molecules, which is number of particles, over 6.02 times 10 raised to the power 23. Times 10 raised to the power 23. So number of molecules will be equal to what? 2.68 2.684 times 10 raised to the power what?
22.
Times 10 raised to the power 22. So that's the answer to this question. So like I said, what we did here is that since they say number of molecule, anything molecule, atom, proton, electron, they are particles. And of course, this is the formula that has to do with particles. This over this used to find n. But we don't know n here. You will now check the question. Does it contain anything that I can use to find n among the formulas given? I have volume and I know my molar volume, which is always the 22.4. Volume over molar volume will give you n. Put the n there and find the number of particles. And this 6.02 is a constant. It has to be there. So that is the case of that one. So we are going to look into another question on mole concept before we go into ideal gas equation proper. So we can take another question now.
Given that 44.0 gram of CO2
gram of CO2
contains 6.02 times 10 raised to the power 23.
6.02 times 10 raised to the power
23 molecules.
3 molecules.
Calculate the number of molecules.
Calculate the number of molecules
in 5.6 dm cube
in 5.6 dm cube
of the gas at STP.
of the gas at STP. So this is direct. This is what we're going to do right here. So we know that we're going to find the number of mole for this one. Number of mole is equals to what? Mass over molar mass. Of course, we have mass here. The reason why I'm using this, normally we're supposed to use number of mole is equals to number of particles over Avogadro's constant, but I need this one to find the number of what? Mole, so that I can chip it into the formula. So N is equals to 44 over molar mass of carbon dioxide, CO2. Carbon is 12, oxygen is 16 times 2, that was to give you 44. So over 44, N is equals to what? 1 mole of this. That's correct. So now we can now find another number of mole for this one here. Number of mole is equals to what? Volume occupied over what? 22.4 dm cube. So the number of mole here will be equal to what? 5.6 over what? 22.4. So what are we going to have here?
0.25. 0.25.
So n is equals to what? 0. What? 0.25 mole in respect to the what? The number of mole for the volume there. So for the first one, remember we said that we have gotten 1 mole. They said it contains what? 6.02 times 10 raised to the power 23. So that means 0.25 moles of that same gas will contain how many? X. Cross multiply. X equals to what? 6.02 times 10 raised to the power 23 times 0.25. X is equals to what? One point
1.505 times 10 raised to the power 23.
times 10 raised to the power 23. So now, what I actually did here is this. They said calculate the number of molecules. Molecule is a particle which is what? Which can only be gotten is number of moles equals to number of particles of Avogadro's constant. But here, there are 2 parameters here. One of these, in respect to the mass, it contains the number of particles, and of course, this one contains a volume. What will not be the number of particles for that one? When you see a question that contains mass, for you to find number of mole, use mass over molar mass. You get a number of mole, and of course, the molar mass is the molar mass of the substance given. So I have to find number of mole again by using volume over molar volume, which is 20.4 dm cube. So I related each of them to their what? To their particles, and then we have 1.505 times 10 raised to the power 23 right there. So now we're going to take another question. We're going to take one more question or 2 more before we now go into the ideal gas equation proper. I think we should save this one then, because